Today we're going to be talking about special right triangles. And these are some special right triangles. You use these a lot in future math classes. So the first special right triangle I want us to talk about is this right triangle where you have, it's an equilateral and equiangular triangle. And I want us to talk about, each side length being x. What happens when I drop a perpendicular down? When I drop that perpendicular down from the vertex down to this side, that actually splits this side in half. So this side is x over 2. That also cuts this angle in half. So this angle here is 30. This angle here is 60. And so we have this third leg, okay, I'm going to call it L for leg. And so to find that leg, we have L squared plus x over 2 squared is equal to x squared. And again, remember, I'm solving for this L. Yes, I realize it's going to be in terms of x. So I have x squared over 4 is equal to x squared. I subtract the x squared over 4 to the other side. So this is an equals here. X squared minus x squared over 4. So that's like 1 minus 1/4. Well, that's 3/4 x squared, and then I square root everything. So L is equal to, I can square root the 3, I square root the 4, that's 2, I square root x squared, and that's x. So this third side is root 3 over 2x. So my longest side is 1. My next longest side is root 3 over 2 times that side. And this third side is 1/2. What if I were to multiply, because we have similar triangles, I can multiply every side by 2. I get root 3 times x. I get x. And then here, I'm going to have that be 2x. And those are going to be important ratios to me. So in a 30, 60, 90 triangle, what I say, it's as easy as 1, 2, root 3. So which one of those is the largest number? That's 2. So that's the hypotenuse. So that side's always 2. In terms of different ratios in similar triangles. Between 1 and root 3, 1 is the smallest, so that goes opposite the smallest angle. And then I have root 3 is left over. So you have to memorize this. So that's why I remember it as it's as easy as 1, 2, root 3, and then you just have to place those along the correct sides. And really what we're going to be dealing with is similar triangles. So for this example, okay, you have PQ is opposite the 30-degree side, PR is X, and QR is Y. So in red, I'm going to put my ratios. It's as easy as 1, 2, root 3 for any 30, 60, 90 triangle. The smallest number, hey, that's 1. The largest side, which is the hypotenuse, is 2. The other leg then, the side opposite 60 is root 3. So set up your proportions. So for root 3 over 3 all over 1, side opposite the 30-degree angle, side opposite a 30-degree angle. is as easy as, and then I'm going to do this triangle y over 2. So really, I have 4 root 3 over 3 is equal to y over 2. To solve for y, I multiply by 2. So now to solve for x, it's the same thing. So 4 root 3 over 3 all over 1 is equal to this side in this triangle, remember corresponding parts, over root 3. So again, remember when I have something over 1, I can just write it like this. Now I cross multiply. 4 root 3 times root 3, 4 times by root 3 times by root 3 is equal to 3x. Root 3 times root 3 is 3. So I have 4 times 3, which is 12, equals 3x. And then I divide by 3 and get x to be 4. So again, another 30, 60, 90 triangle. I need to solve for BC. So again, in right, I'm going to write in what the typical side lengths are. It's as easy as, again, 1, 2, root 3. So 1 is the side opposite the 30-degree angle, since that's the smallest. The hypotenuse is the largest. The side opposite the 30-degree angle, I'm sorry, the 60-degree angle is the root 3. So since I'm solving for BC, BC over my common piece in any right triangle is equal to this side in this triangle, 4 root 3, all over root 3. Well, look what cancels. Those root 3's cancel. BC over 2 is equal to 4. Multiply by 2, and we get 8. So that was our 30, 60, 90 triangles. We also have another special triangle where we have an isosceles right triangle. So if those sides are equal, this side, this angle is 45, 45. So this is for a 45, 45, 90 triangle. So a 45, 45, 90 triangle. So I'm going to call this side x. X squared is equal to 1 squared plus 1 squared. X squared equals 2. So this side now, I'm going to call that root 2. So 1, 1, root 2. And remember, root 2 is bigger than both 1, so that's the hypotenuse. So again, a 45, 45, 90 triangle. Each of the legs are 1. The hypotenuse is root 2. So solving for A now. Okay, those are both of the legs, those are both equal, so that's our one side. 8 is our root 2 side. So 8 is to root 2 as A is to 1. I can't have a radical in the denominator, so I multiply by what that radical is. So A, that's an A, not a 9. On the top I have 8 root 2. Root 2 times root 2 is 2. Since these are being multiplied, I can cancel the 8 and the 2 to get a 4 root 2 is equal to A. Okay, each one of these sides is equal. So I know it's an isosceles right triangle. So I know that that's 45 degrees. I know that's 45 degrees. This side is 1, root 2. So x is to root 2 as 6 root 2 is to 1. I cross multiply x equals 6 root 2 times root 2. Well, that's 2, so x in this case is going to be 12. And this hypotenuse is always whatever this side is, it's always my leg times by root 2. That's what my hypotenuse is. Okay, I have a 45-degree angle, I have a 90, so I know that that is 45. I know this side is 9. It's as easy as, since it's a 45, 45, 90, 1, root 2. So x is to root 2, x is to root 2 as 9 is to 1. I cross multiply. And again, remember on the last slide, I just told you the hypotenuse is always leg times by root 2. So you could have easily put that if you wanted to. Okay? So that is my video on special right triangles. Thank you for watching.